Hello, Precalculus students. This video is for Precalculus Chapter 1.3. So we are looking at behavior of graph and particularly rate of change and how it affects graph. So if I have a function, if the function is not a line, then it would change. The y will change up and down, right? Even if it's a line, y will change, but they change in such a way that the rate of change is constant because for linear line, that is what it is. But if I have a function like this f function is going up and then down, in between 2 points, they did change. They go through a higher number and then they drop back. But if we are looking at how much it changed just between these two, ignoring what has happened, we can actually calculate a value called average rate of change. That means just look at this 2 point, ignoring all the ups and downs. What is the change by just considering the 2 points on the graph? And you can do that by drawing a line called a secant line. This secant line just join these 2 points that is on the graph and find the slope of this line. So this particular value, which is the slope of the secant line, is called the average rate of change of f between the 2 points, or at x equal to 1 and x equal to 2. So meaning at this interval that start at x1 and end at x2, that is the average rate of change. So average rate of change is pretty much calculated like as if you're calculating slope is change of y, change of output, and we call it delta y, divided by change of input. It's a ratio. So it's a ratio of delta y over delta x, and mathematically it's actually just y2 minus y1 over x2 minus x1, just like a slope. So sometimes we use the abbreviation slope. Slope is m, right? Slope of a secant line for AROC, average rate of change. And you can think of it as function of x2 minus function of x1 over x2 minus x1. Okay. So let's see. Somehow we recorded the cost of gasoline per gallon. Y is year, and then C is the in dollar value, how much gasoline costs. So you can see that it fluctuates up and down. It goes up a little bit at 2008 and then drop down and then goes up again. But if we are to just look at 2006 and 2012, if I look at just ignoring the ups and downs, we can say, okay, from 2006 it was 262, 2012 is 368. What is the average rate of change? So we can calculate something called AROC by looking at the y value, y2 minus y1 over x2 minus x1. So y value is for the later year is 368 minus 262 over what is the difference of year 2012 minus 2006 is 6. So put in the calculator, so that would be 3.68 minus 2.62, 1.06 divided by 6. So 0.18. Now the units of this is $0.18 per year. We obviously see that Y actually increased, but it increased on average per year 0.18. Now, actually, it does not increase 0.18 every year. Actually, it goes up and down. So that's why we use the word average. That means on average, looking at just the 2 year, that's how much it increased. So likewise, we can calculate AROC, average rate of change, of any function or any that is documented as a graph from 2x value. So at x equal to 1 to x equal to 7, or x7. So this should be x equal to 7. Okay. So we will read off the y value because they only tell us the x value. So when x is equal to 1, we write down 1, comma, 5, right? And then when x is equal to 7, we have 7, 3. So if I mark this 2, Although it goes up and down between 1 and 7, we ignore this and we just look at from here, from 1 to 7. Actually, there's a going down, right? So the average rate of change would be, AROC would be the ending number, 3, minus the beginning number of y, 5, over 7 minus 1, just like as you're doing slope. So that is negative 1/3. So it's a decreasing. It's a decreasing. In the real situation, it was decrease and then increase and then decrease. But between the two number, it is. What about from 2 to 5? So we have to do the same thing, right? Read off 2 and then do 5. At 2, the y is 3. At 5, the y is what? The y is 7. So AROC in this interval, sometimes they just say interval 2, comma 5 also. So the AROC would be 7 minus 3 over 5 minus 2. So it's 4 over 3. So it is positive, right? Positive. So that means every change in y, x is going to increase 4 over 3. And you can see the AROC between any two number could be different. So when you have a positive number, that means it's the y has increased when it moved from x equal to this to the other one. So what about if my function is actually a function value? So they would say, what is AROC from -1 to 1? So -1, we have to plug in -1, right? So do it here. G of -1 is equal to -1 cubed minus 2 times -1, so that is -1 plus 2 is actually 1. So we have a point of -1, 1. What about g of 1? Because at x equal to 1, we want to know the y value. So this 1 minus 2 is -1. So 1, -1. So what is AROC? AROC would be -1 minus 1, y2 minus y1 over x2 minus x1. So it's -2 over 2 is equal to -1. It's a decreasing, right? So y was 1 and then it decreased. But what about from 1 to 2? So from 1, we have g of 1 calculated already is -1. And then what about 2? So g of 2 is 2 cubed minus 2 times 2. So it is 8 minus 4 equal to 4. So we write down 2 comma 4. So AROC would be 4 minus -1 over 2 minus 1, which is 1. So it's 5 over 1 equal to 5. So this is increase. So we can compare the AROC, we say from negative to 1 to 1, y actually decrease. They have different sign. They're different sign. And from 1 to 2, actually it increase. Okay, so AROC is very useful. No matter how your graph fluctuate, if you only want to interest at looking at how much a particular the function increase or decrease, you can do AROC. So let's do the interval 1 comma a. That means x equal to 1 and x equal to a. This is how they write it. These are all x value, is not the y value. So let's do g of 1. G of 1 is 3 times 1 squared plus 1 equal to 4. G of a. G of a is 3a squared plus 1, right? So we have 2 points, which is 1, 4, and also a comma 3a squared plus 1. So this point is kind of funky, but if we want to do ARC, we just do the same thing. Y2 minus y1. 3a squared plus 1 minus 4 over a minus 1. So it'll be 3a squared minus 3 over a minus 1. Do you see that you can simplify? 3a squared minus 1 over a minus 1 factor equal to 3a plus 1, a minus 1 over a minus 1. So a minus 1 and a minus 1 are the same thing. So minus 1. So this cancel, it's ultimately equal to 3a plus 3. So this particular way of doing things are what you will be doing in calculus also. Okay, so this is understanding AROC and it's important. The next thing is about properties of graph. If you actually, unlike the other situation where you have only the function, you actually see the graph. Can I tell the interval when the graph y, not the graph, but y is increasing, decreasing, and also can we tell when it increase to the highest point at a certain area and decrease to lowest point in a certain area? So that would be the next video.